today we're going to talk about some rules that will help us prove parallelograms are actually parallelograms. Okay? We did something similar in an earlier chapter with other figures, and now we're going to apply the same concepts with parallelograms. This are going to be what is the least amount of information we need to know to prove that this four-sided figure is actually a parallelogram. Okay? That's where we're headed. And so all of these theorems, I've numbered them 1 through 4. There's 4 of them. All of these theorems are to help us prove that a quadrilateral is a parallelogram. Okay? And you'll see that they are very similar to the properties of parallelograms we learned the other day. I'm going to move this up just a little bit, and then I'll pause it so you can copy, and then we'll make sure we talk about it so you understand. Proving quadrilaterals are parallelograms. I'll read through these just to make sure you can read my writing. The first theorem says, if the diagonals of a quadrilateral bisect each other, then it is a parallelogram. The second one says, if one pair of opposite sides of a quadrilateral are both congruent and parallel, then it's a parallelogram. The third one says, if opposite sides of a quadrilateral are congruent, then it is a parallelogram. The fourth one says, if opposite angles of a quadrilateral are congruent, then it is a parallelogram. So this might be a no-brainer to some of you, but I'm going to draw this out anyway. If these are the diagonals of a quadrilateral, and we know that those two are equal and these two are equal, then this first theorem is saying that since segment PR bisects segment LA, and since segment LA bisects segment PR, so this point right here is the midpoint of both segments, both diagonals, then that means this has to be a parallelogram. Okay? Do you agree that these are vertical angles?
Yeah.
Okay? Do you agree then that this triangle here and this triangle here would be congruent by side angle side? So that means these sides would have to be equal, right? By CP/CTC? Would you agree with that?
Yeah.
Okay. And do you agree that these are vertical angles? So that means these triangles are congruent by side angle side also, right? Making these sides congruent by CP/CTC, okay? And we could get into then saying then this angle here must be congruent to this angle here because of CP/CTC, right? And if you look at this picture, that line is my transversal and these are my other lines. Then these angles here and here are alternate interior, aren't they? And just a moment ago, we were talking about since alternate interior angles are congruent, then those lines have to be parallel, right? And then again, we could do the same thing with these that we proved up here. And then we'd be looking at these lines. And this transversal. And those are alternate interior angles congruent, making these lines parallel. So if I have two pairs of parallel lines, what shape is that? Parallelogram, right? Now, that was just quickly talked through, okay? I'm not expecting you to write the proof on that, but I want you to see that there is reason that this is enough information, because we could then take that information and prove these opposite sides are parallel. We could prove opposite sides are congruent. We could prove anything we want about it, okay, with that little bit of information. And we could do that with all of these theorems, the second one, the third one, the fourth one. All of them will give us enough information to do something similar to what I just did, okay? I don't really want to take up your class time to do that, but I just want you to understand it can be done, okay? So the other one is saying, if we have one pair of opposite sides congruent and parallel, I did a lot of mess on this, so can't erase lines. All right, so the second one, what they're saying is if I have one pair of sides that are both congruent and parallel, then that would be enough information. Again, we could draw a transversal in here, okay? Because lines are parallel, we could prove those are congruent. We'd have this congruent to itself. We'd have side angle side. And we prove these two triangles are congruent. And then we could take that information and prove all we want to know about opposite sides being parallel. Okay? So we won't go there, but that's what can be done. All right? And the third and fourth one are saying if these sides, oops, here. If these sides are equal and these sides are equal, then that's enough to prove it's parallelogram, okay? When sometimes people want to build a garage or pour a slab of cement, Cindy, pay attention, okay? Sometimes they want to do that, and they'll take a stake and they'll measure the distance they want it, and they'll put another stake. Then they'll measure the distance they want this side, and they'll put a stake, and they'll measure this same distance here over here, and they'll put a stake, and they'll measure that distance, and they'll make sure these are equal, and sometimes they'll think, there, now I've got a rectangle. Okay? That may or may not be true. The only thing that is true is you have a what? A parallelogram. Because you've made sure that opposite sides have the same length. All that proves is that you have a parallelogram. And if I exaggerate that, oops, it could look like this. Okay? My shape could look like that and not actually a rectangle. So we have to be a little careful if we're building, and later on in a later chapter, I'll show you an easy way to make sure that your parallelogram is a rectangle. But right now, all you need to know is that if I have opposite sides of a four-sided figure are equal in length, then that proves I have a parallelogram. That's all it proves. Okay? And I agree a rectangle is a parallelogram, but not all parallelograms are rectangles. Okay? So be careful of that. And the last one is opposite angles. And that's just saying if I know these are equal and I know these are equal, then I know it has to be a parallelogram. Even if I don't know anything at all about the sides, it has to be a parallelogram. Okay? All right. Any questions on those four items? All right. Okay, your assignment today, 3 to 48 by 3s, and then the checkpoint quiz at the end of the lesson. So we'll have a quiz coming up probably Wednesday. I'll put our calendar together today least in my mind. I may not get it on Schoology yet, but at least I'll have it laid out what we want to accomplish, okay? So, that'll be what we're doing. Any questions?
No.